Hello everyone, this is Dr. E, and for today we're going to be proving triangles that are similar according to the postulates and theorems that we're going to be discussing today. We know in geometry that polygons or two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. Now for today we're going to be focusing on our specific polygon, which is a triangle, and use its postulates and theorem to prove that they are similar. So in this first postulate that we're going to be using, we have the angle similarity postulate, which says that if there are two angles of one triangle that are congruent to two angles of another triangle, then the triangles are considered to be similar. So if we're going to visualize the two triangles, let's say I have triangle A, B, C, and triangle L, M, N. If we have corresponding angles or two corresponding angles that are congruent, let's say angle A is corresponding to angle L and they have the same measurement as well as the measurement of angle B and angle M. They share the same measurement, therefore triangle ABC is considered similar to triangle LMN using the angle-angle similarity postulate. And this is how the diagram works when we are looking or using this postulate to prove that the triangles are similar without using all the corresponding angles and all the side lengths of our triangle. So similarly, if we have these two triangles, triangle SRT and triangle MLP, if triangle S is congruent to triangle M and triangle R is congruent to triangle L, therefore the two triangles are considered to be similar using this postulate. So for example, we have two triangles that you are seeing right now. We have triangle RSW and triangle VSB, and we need to show that they are similar. We can use the angle-angle similarity postulate because we are already seeing two congruent angles, that is angle R and angle V, which are both 45 degrees. And by doing this, all we need to do is to show another angle that is congruent. And even though we're only given one angle measure, which is 45 degrees for both R and V, we know that we can have angle 1 and angle 2 and prove that they are also congruent for the reason that 1 and 2 are what we call as the vertical angles. Therefore, we're able to show that we have two pairs of corresponding angles in these two triangles that are congruent. So we can say that triangle RSW is similar, not congruent, but similar to triangle VSB using the angle-angle postulate or angle-angle similarity postulate. So if we have two separate triangles, JKL and PQR, we are seeing that we only have angle L and angle R that are congruent, which are both measuring 70 degrees, but angle J and angle Q are 85 and 30 degrees. So to use the angle-angle similarity postulate, we need to prove that angle K and angle P are congruent. And to be able to do that, we're going to be using our basic theorem about triangle, wherein the sum of the interior angles of a triangle is equal to 180 degrees. So if we're going to find the measurement of angle K, all we need to do is to equate 180 degrees to the sum of angle K plus angle J plus angle L. Now we know from our given triangle JKL that the angle J is given, which is 30 degrees, and we also know angle L, which is 70 degrees. We don't know what angle K is, so using algebra, we'll be able to solve for the measurement of our angle K by adding 30 and 70, which is equal to 100, and by subtracting 100 on both sides. I can't write. 100. We know that the angle measurement of x is equal to 80 degrees, so therefore angle K is equal to 80 degrees. So with angle K being 80 degrees, all we need to do is to prove that angle P is also 80 degrees with the same manner. So using the sum of our interior angles of a triangle being 180 degrees, we're able to show the measurement of angle K, because we already know that angle L and angle R are both congruent. We just need another pair of angles to be congruent because J and Q are definitely not the same. So in this case, we were able to prove that angle K is equal to 80 degrees. And for angle P, we are seeing that angle P is equal to 25 degrees, and they are not the same. So in this case, there are no angles here that will be congruent for the first or two pairs of angle that is required to show the two angles are similar. So we know this time that triangle JKL is indeed not similar to triangle PQR because we are only seeing two angles that are congruent. So this is the AA similarity postulate, and the other two theorems that we're going to be using to prove that two triangles are similar would be the side angle side similarity theorem. And we are seeing here two triangles, and we know that angle A and angle Q are congruent, and its corresponding sides AB to RQ and AC to QS are both proportional. Therefore, triangle ABC is similar to triangle QRS. So this is how we use the side angle side theorem to be able to show that two triangles are similar. And the other theorem that we're going to be using today would be the side-side-side similarity, which is showing that the corresponding sides, or if the corresponding sides of our side lengths are proportional, then those two triangles are considered to be similar. And in this case, AB is corresponding to QR, and AC is corresponding to QS, and BC is corresponding to RS, and all their ratio will be the same. So using the side theorem or similarity theorem, we're able to prove that triangle ABC is similar to triangle QRS. And how are we going to apply these two similarity theorem? Let's observe these two triangles, triangle UST and triangle VWX, and we know that there's no given angles in this triangle, so we are going to be using the SSS theorem because we are given the measurements of the three side length of triangle UST and triangle VWX. The only thing that we need to do here is to show that they share the same ratio when it comes to their corresponding side lengths. So let's start with our reference angle. And here my reference angle is the right angle T and right angle V to be able to show the corresponding sides without confusion so that I would know which pairs of side lengths I will use for the first pair. And my first pair would be the hypotenuse or the longest side of our triangle, which is triangle US and triangle XW or WX, and we know that the measurement of its sides is given by 10 and 15, and using the ratio of 10 and 15, I can simplify the ratio of US corresponding to WX into 2/3, and now all we need to do is to check if the other two corresponding side lengths will have the same proportion as US over WX. And the other side that I'm going to be testing would be the shortest side, and my side would be the vertical line ST and xv. And we know that the measurement of these two side lengths are given, which is 6 for st and 9 for vx. And for simplifying our fraction, we are seeing now that the ratio of us over wx is the same with the ratio of st over xv. And to further show that our last sides corresponding sides have the same proportion as the first two sides, let's show that ut all over wv will have the same ratio as the first two pairs. So we know that we have 8 and 12 for the measurement of TU and VW. And by simplifying the fraction, we are seeing that all three sides share the same ratio. Therefore, we can say that triangle UST is similar to triangle VWX using the side-side-side similarity theorem. So this is how we use these theorems so that we don't need to prove the basic definition of similarity, wherein corresponding angles should be congruent and corresponding side lengths should be proportional. And by using only three information about the triangles, we'll be able to prove that they are similar. So for our Numberbender challenge of the day, we are seeing two triangles, triangles TUV and triangles QVP. Let's see how you are going to prove that they are similar using the theorems and postulate that we have covered for today. So for our lesson on similarity, we don't need to prove that every corresponding angles are congruent and every corresponding side lengths are proportional. All we need to do when it comes to triangles will be to use the three or the postulate and the two theorems that we have covered, and you'll be able to show that two triangles are indeed similar. This is Dr. E, and see you again next time. Bye!